Good afternoon, my name's Wright and I'm going to give you a quick overview of what we've been doing with vector search benchmarking over the last year. If you're interested in all the background to this, articles will be available on developer community as soon as we can get them up there. But I'm just going to go straight here to the what it all means highlights. Let's just give you an idea of what's in the real content if you want to go back and look at it. So what does this all mean for your application? Well, if you're using unindexed search, unindexed search is the only option if you want guaranteed exact results. If you want ground truth, you have to use unindexed search. If you do use unindexed search, it's expensive from a compute and a calculation perspective. Try and keep the data set as small as possible and keep it all in global buffers. Restrict the dimensionality. Don't have more dimensions in your vector than you need. More dimensions locate your vectors more precisely in vector space, but they come at a cost of storage and compute overhead. So just choose the model that's going to give you the location precision that you need and don't use any more than that. If you're using approximate nearest neighbor searching, if you're using our indexing, understand recall. Understand recall. Recall is the metric by which we quantify how good a match the approximate result set is to the ground truth result set. Understand how it's calculated. We've got some code we can share with you to do that. Understand how good it needs to be for application. 90% is probably the bare minimum, but you can tune that up and down using the indexing parameters that we provide in the index definition. Index time resource requirement is going to be different from query time resource requirement. You're going to need a lot more resource when you're building the index than you are when you're querying the index, a different type of resource. So your index build is going to be resource intensive. It's going to read through all your data. It's going to use a number of background jobs running in parallel to build the index. So you want to make sure that is as efficient as possible. So fast storage, use the work queue manager to make sure you've got the right number of jobs running, and in the full details we'll tell you how to calculate that. One thing I will mention here, IOPS constrained. If you're running this in public cloud, think about the IOPS you need to run this, think about the IOPS your instance gives you, and either move to a different environment or temporarily up your IOPS limits, or you're going to get terrible performance. And again, the key to good performance is having the data in global buffers. If you have to go out to disk for the index globals, it's going to kill your performance. So this time, keep your index global in buffers, make sure it's there, pre-fetch it if you need good performance from first access. And remember, this is new stuff, but underneath it, it's the same stuff. Make sure your system management, your iris system management is good. Make sure you're taking care of your compute. Make sure you're taking care of your journaling. Make sure you're taking care of your global buffers and so on. Well, thanks very much, and go to the main article if you want more detail. Thank you.